IoT Unplugged, where we talk to industry leaders, innovators, and major players in the Internet of Things, bringing you the best and latest insights. Tune in to learn more. In this episode, I'm joined by Eystein Stenberg, CTO and Co-Founder of Northern.tech, as he talks to me in the wake of the publication of their report into device lifecycle management, touching upon key takeaways for companies with devices in the field. Hi Eystein, thank you so much for being here.
Hi, thank you.
Could you start us off by talking a bit about who you are?
Yes, so I am one of the co-founders of Northern.tech. We're a software company out of Norway. It's our headquarters. I lead product development, have more of a technical background. And the company has been working on system management for both like cloud infrastructure as well as now in IoT. So basically making sure that devices that are in the field are healthy and up to date and under control by the OEM or the manufacturer, basically. And we also have a strong background from security because that is a big aspect of it as well.
Yeah, well, we will definitely talk in a little bit about device lifecycle management in the context of security because it is so important. But before we do that, why don't we look at the state of IoT security today? In your opinion, what are the biggest challenges? What are the greatest threats? What have you seen from your position?
Yeah, that's a good question. It's a broad topic, and I think in general, since we've worked both in cloud environments and IoT, there is definitely a difference in maturity. So in IoT environments, it's a bit earlier in the maturity curve. Still, like the OEMs, the companies, those who make those devices, they know it's important, and some are starting to plan it. Some have implemented some solutions, but I think it's more on the execution side that we see the gap there. And if you remember or know the history where IoT is coming from, it's basically embedded devices. So like any kind of device that had like a microcontroller running some software. It could be even something silly like your TV remote. It has some software on it. Or like a door opener. You push a button and then the door opens. And maybe there's a display there, but it wasn't connected. That's where like IoT came from. So very simple software, mostly built in-house, maybe 100 lines of code or something like that, and it just did one function. And it was fairly easy to test and try it. But then, of course, complexity grows. You get more advanced operating systems. You get a higher, like more advanced user experience with displays, touch, connected to your app on your phone. It has to go over the internet, so then it gets connected as well. So I think you can kind of see a little bit of that legacy where OEMs aren't necessarily aware or that experienced in the software aspect or the digital aspect of IoT and the connectivity. So you will see issues around that. I think mostly around connectivity. If you didn't expect the devices to be connected in the first place, or you kind of not used to that, it takes some time for companies, especially big companies, to kind of change their processes and the culture around this.
Yeah, I mean, I think you raise a really good point when you talk about the history of IoT, starting with connecting devices, the code being quite simple, and then becoming more complex, because it's still it's not necessarily new and novel, but it's still quite a young industry, and so I think perhaps it could just be a matter of time and a matter of companies such as yourselves helping your customers with understanding the security involved in writing code and connecting devices.
Yeah, absolutely, and I think it's also transitioning a bit more into of an ecosystem where there are different vendors that specialize in different things. Because let's say in the older days, usually OEMs, they would buy, or the end manufacturers, they would buy almost everything from one vendor. They could buy like both the software, the hardware, maybe the packaging they got from another vendor, but there weren't that many vendors. So the OEMs would purchase more of the whole solution. But I think now it's transitioning more into of an ecosystem approach gradually, so that OEMs, they need to become a bit more technical themselves, understand like all the pieces at some level, and then they find vendors that can supply the best of breed solution for each of those pieces, such as over-the-air update, device management, but semiconductor like chips, hardware, and even doing the PCB, the hardware design, maybe in-house a bit more. So that's what we're seeing, a bit more of a specialization, and I think that is also expected as the industry matures.
It sounds like there's a little bit. It's a little bit more challenging, but it sounds like you ultimately think that's a good step in the right direction in terms of having a wider ecosystem.
Yeah, I think so. I think it's a natural step. I think if you look at the cloud infrastructure, we were involved in that in the early days. We see some parallels there in the servers, like Amazon and this early Google. They would buy their own servers, put them together, put them in a container, plug them in, solve all the infrastructure problems. And today it's not like that. Like if you want to start or have a website, you can buy that hosting only from other companies. So it is part of the maturity, I think, and it would enable a lot more companies to innovate over time here. That lowers the barrier of adoption. So yeah, ultimately, I think this is definitely a good thing, and it's a maturity, how the industry matures over time.
Sure. So you mentioned complexity earlier, and I thought it would be interesting to pick your brains on software-defined vehicles as one application where it's credited as an area where the software's become quite complex and the number of different software running on a car is quite complex. So what have you observed in this space?
Yeah, that's a great question. I think cars are very important or interesting. Also, they're kind of the most advanced and most complex kind of IoT devices, if you would call them that. The reason is that you also have a lot of. It's kind of the hardest of both worlds. So you have a lot of complexity. You have a lot of small computers, or ECU, electronic control units, as they are called in cars, but they're basically like a little computer. So for controlling the brake, the infotainment system, even the blink lights and these kind of things, they are all in there, and they communicate with each other. And then, especially in terms of over-the-air updates, if you're going to update those, you don't want to update just one at a time, because you don't know if they will be compatible with each other. So you have to have like a strategy where you can update the whole vehicle, and then you multiply that with the scale of the vehicles and the different models you might have. Like you switch out one component in the 2020 model and another component in 2021 model, and you can just imagine like the complexity of managing this is very high. And on the other hand, you also have a very big safety threshold here in vehicles, so you cannot afford anything to go wrong. And on top of all that, you also have a lot of competition, and the market is changing a lot in automotive right now with these software-defined vehicles. All OEMs have some program to invest in software-defined vehicles, accelerated by EVs. There's new platforms. But it's really important to solve that problem of being able to update these, because there's so much software. I don't remember, but maybe it's like, I think there was like 100 million lines of code or something in a vehicle, so it's getting quite out of hand. So the keyword here in terms of over-the-air updates is software configuration management. That's what they call this, updating the whole vehicle as one product, basically. And that's something we're working on as well to help achieve. But it's a very difficult problem. And the only thing that the OEMs can do, basically, and what they are doing is, like I mentioned before, to become more involved and understand each component more, become more technical, and then handle this as a more of an ecosystem approach, because it's not and get vendors that can solve each of the components. It's not something they can all build in-house, I think.
And you see that from your customers and asking you questions about what's involved, what they need to do?
Yes, for sure. Especially in terms of over-the-air updates, device management, device lifecycle management, which we specialize in. They ask questions about that, but I think most of all they just want it to be solved. Like they have other priorities, because and this is true for the general market. Like, if you could call IoT a market, like all companies doing something in IoT, that they just want the product to be launched and compete in the market. They don't want to spend time on developing the over-the-air update infrastructure, or figuring out how to manage devices, or the keys, or the vulnerability scanning. Like, they don't necessarily want to implement all that themselves, because they have other priorities. This doesn't make them any money, right? So they want to focus on their core competence, or the kind of the core product deliverable.
Which I think is probably a good time then to talk a little bit about what you specialize in, which is over-the-air updates and device lifecycle management. I think one, and perhaps you can comment better on this, but one issue that's raised with the IoT industry is that devices get connected, they get left out in the field, and then they don't necessarily get managers, and they're not regularly updated, and of course there are security risks that come with that. So what would be some best practices that you would say would help IoT companies, and indeed every other company that would have a connected device left out in the field?
Yeah, I think these kind of things are best dealt with at the design phase. So when you start planning a new product, and typically what we see from our customers is that it takes about like 2 to 3 years from you start planning a new IT product until it's actually in the field. And security, over-the-air updates, and this kind of infrastructure, and key pieces to how you manage the devices, they should be planned at the design phase, like before you get out in the field. And I can give you one example, is that it's very hard to retrofit some things. So, for example, in terms of over-the-air updates, a very important thing that we focus on is what we call robustness. You could also call it reliability. But basically, when you put devices in the field, whatever they are, if they're a vehicle or like a camera, or what it could be, like, they're in a bit of a hostile environment, or uncontrolled environment in terms of network power. You don't really know what's going to happen. Is the user going to unplug it while you're doing an update, for example? And then when it starts again, is it going to be half updated and not start? And then there's like a recall, or not recall, but like they would have to go physically to the store to get it fixed. And to get into all these issues, and this example is very difficult to. So vendor can do this. So if you which is one of our products, is if you unplug the device while it's being updated. This is something we have designed for. So this will work because we are not overriding what you're currently running. But if you cannot retrofit this has to be designed. Like, when you make the device in the design phase, you have to make sure that there are 2 different places you can write the update to. And that's kind of how it's designed. So yeah, that's one example. So I think that would be my main thing, is that you need to design for this early. It will save you a lot of pain down the road, let's say. If you're already in the field, I think it's a bit harder. Maybe you can work on something on the networking level, like firewalls and things like that, to limit what's going on. If it's in a building, that's easier. If it's like a sensor in agriculture field, it's harder to control the network than it's usually over cellular. So it really depends a little bit on the case. you're in here. But in general, I would say like plan it early.
Yeah, which I think is a good just general philosophy to apply to life, right? Just plan in advance. But in your experience, I'm just curious to know, in your experience with the people that you work, the customers that you have, are you finding that you're having to advise less? Just make sure it's in the design. Are you noticing that customers are having this, or are you still seeing issues that come out of not putting it in the design and then struggling with, for example, retrofitting?
So when let's say 8 years ago or so, I think about half of the customers we talked to didn't plan, didn't have a plan or a way to update the devices, for example. Today, we find that almost everybody has some way to do it when they get it out of the gate. So I think you can see the majority. It's like people are planning more, but still, like the solution they have might not account for all the issues that they might see in the field. I think the situation is improving. So we see more requests now for like from customers who know kind of what problems they want to solve, and then they're just looking for a solution that will fit their needs. Whereas in the past they didn't usually know that they needed something like this, or at least up front. But I think, as they launched products in the field, they got that experience, and they also discovered how hard it is to retrofit and how hard it is to build things themselves, where it fails at scale, and then, okay, we don't want to do this again for a new product. So I think it's definitely going in the right direction. In that sense.
Great. No, that's great to see. That's great to hear. I think we're at a very interesting time as well, because we've got the Cyber Resilience Act coming up. I think the deadline is 2027 to get everything in order. One thing that's kind of mandating, if I may simplify it for the sake of brevity, is that you need to be aware of what's going on in your device. You need to be aware of security updates. You need to make sure that you're on top of that. So what kind of impact do you foresee it having on device lifecycle management? Do you see it encouraging more companies, for example, to ensure that they have those best practices in place?
Yes, for sure. I think it impacts some companies more than others. So the scope of the companies, let's say, is those that are selling connected devices or connected software even in Europe, which I guess is most companies in the world. Even if you're an American company, you need to comply if you're selling in Europe. I think some products, they probably already comply with it. There are other security regulations and standards out there that companies already comply with, and then if they then they need to add a CRA, and it's a lot about like processes. It's not very prescriptive. It does say, like you mentioned, that you need to have a way to do security updates. And there needs to be a way to manage vulnerabilities. You need to have a process for how do you do this, but it doesn't say exactly like how should the devices be updated, or how frequently do you need to scan for vulnerabilities, or which tools. It doesn't like. So it's kind of up to the organizations to define those processes, but they need to be in place and documented. So some organizations already have this, so they would just need for other standards or just for internal security. So they would just need to adjust this or add one more to it, and that's not going to be a big challenge. But others, and I think the ones that this regulation is targeting more in terms of cybersecurity, are manufacturers that have been a bit too loose maybe on the cybersecurity side. I think those mostly affected are like lower cost products maybe. So you can think about things like toys or more in the consumer electronics category, maybe some Wi-Fi routers. There have been like classic attack surface for hackers. It is like most regulations. I think it's going to lift the floor of the cybersecurity, so that at least there's some baseline for all manufacturers, and those that are far below that baseline now are the most affected, is what I would think. But there is definitely a lot of interest in this. We've been to conferences earlier this year, and all the rooms about Cyber Resilience Act, they're full beyond capacity. And we also see it in the report that we made, that most companies do have some plan in place, or they're in the planning phase. I can see if I find. So about 20% of OEMs have a compliance plan, so it doesn't sound like too much, but the others, they're definitely aware of it, and they're in the process of planning, and they still have some time to figure it out. I believe actually the reporting, there are 2 deadlines in November 2025 is a reporting deadline. So at that point, you need to report if you find that there are vulnerabilities being exploited in your product. You have to report it to the authorities and also the users of your product. And November 2026, you have to be in full compliance. So that means you also need to be able to update those products. And it sounds far out, but if you think about like what I mentioned earlier, like a typical launch phase for a new product is like 2 to 3 years. We're just over like around 1.5 years away from the full compliance now. So it's getting closer.
Yeah, I think in the grand scheme of companies, 1.5 years is not very much time. Now that we're getting closer, but I think the image you gave of going to a conference and the room where they're discussing the CRA being packed is quite poignant, because I think it definitely speaks to not only the interest and the need to know more, but just wanting to understand what is required for each and individual company, and that clarification I think is so important. So I think it will definitely be interesting to see what happens in the next few years, even beyond the timeline, because at that point that will be when compliance is in place. You have to comply, so it'll be interesting to see what comes out of that. Just kind of veering away from that topic a little bit, what role do you see open source, for example, playing in building IoT infrastructure? And do you have any examples that you can speak about?
Yeah, I think open source in general, I view it as a little bit connected to commodity. So if like something is being used by a lot of different companies, and it's kind of a baseline layer, so you can take historically like Linux, like an operating system kernel, for example. It's something that everybody who has a computer needs. And there's a lot of things you need around it to make it useful, but that kind of core, everybody needs, and it doesn't actually provide much differentiation. You just need it, right? And it needs to work. So I think like historically, that's where like maybe people have different opinions about it, but I see at least in terms of the commodity layer, let's call it that, usually like at the bottom of application stack, like the operating system, the kernel, maybe some of the middleware, things like that. That's its kind of strength, because that's where it makes sense with more reusability and lower costs, and there's less differentiation there. And one of the big, like aside, okay, it's usually free, but then one of the big benefits to businesses, I think, using open source is avoiding lock-in. So that's what we see from our customers too, especially for critical software like we develop. The device is going to be out there for 10 years, maybe more, 20 if it's in automotive. And if you're then locked, like the time the product goes out the door, you're locked into one single vendor. That's a challenge. And this is where open source also can play a big role, which we do with Mender. We have the our over-the-air update solution, we have a open source core offering. And this is one of the business models that have really proven out to work in open source. So the core solution, so you can use all the basic functionality, let's say the commodity functionality, as open source and free and without lock-in. You can use your own servers, your own infrastructure. But if you want value adds features, for example, more advanced security, like isolating which, like role-based access control, which users can do what, some users can deploy updates, other users can upload new software to the server itself. Then those are more value-add features that you can, that we generate revenue from, basically, to support the whole. So I think this model works really well, and it aligns with kind of, I view open source more like commodity that we can collaborate on rather than competing on that layer. And in IoT and embedded in particular, I think it's quite interesting because it's such at the lower layer, like the hardware, integrating with different hardware is a major pain point in IoT. And this is where open source community can also help. Like a lot of hobbyists, they like buying new hardware and they play around with it and they can share how they integrated Mender or other solutions with it.
It's definitely something that is, it's helping accessibility, it's helping democratize technologies, and it's probably definitely something we could devote a long time talking to, and I would love to talk to you about it for a long time. But in the interests of time and in the interests of wrapping up the episode, is there anything you want to mention before we finish to our listeners?
I think that I would advise to try to distinguish between what puts your business apart if you're running a company, and focus on that, and not so much on what you could do, because there's a lot of things you could spend your time on, but what really makes a difference in the market for your customers. And then I would try to either find open source components that work well, are trusted, or commercial vendors that can supply what you need overall as a product. So that, I think, is my main advice. I've just seen a lot of reinventing the wheel, which doesn't turn out that well in the end.
It's definitely the temptation in technology and those working in technology to think, I've got to do something brand new, I've got to do something exciting. But really good takeaways. I hope those listening take them on board. And otherwise, thank you so much, Eystein, for joining me and for talking a little bit more about device lifecycle management.
Of course. Thank you so much for having me.
IoT Unplugged.